we can detect the need for recursive partitioning during phase 1 when we generate an output partition that is greater than B pages. We will deal with that partition during phase 2. What happens in phase 2 for that partition is that we recursively sub-partition it into its own partitions. Again, it is important to do this with a new hash function h sub p1 that is independent of h sub p, as otherwise all the tuples would end up in the same partition again. Here with h sub p1, we scatter those tuples across different partitions. And then continuing the recursion, we do the conquer phase of the recursive call to generate output partitions that are contiguous on equal values. And when we are done with that recursive phase, we pop back out of the recursion. What we have effectively done is that we have hashed the first of our partitions into one big output partition that is now contiguous for all equal values, and we can move on to the next partition from the outer part of phase 2. From the previous discussion, you may have observed a bit of complication having to do with very frequent duplicates. So consider a dataset with an extremely frequent key, like, for example, in a big table, a column called gender, where the options are male, female, or other. We have a lot of males, a lot of females, and perhaps a lot of others as well, but there aren't very many different values for the data to be partitioned across. So if we have many millions of rows, we will have a lot of M's, a lot of F's, and maybe a lot of others as well. That might result in each partition having size greater than B. So what do we do here during recursive partitioning? Well, let's think about it. After we divide the data, we only get 3 buckets that are non-empty: M, F, and other. Then, when we have to recursively partition because there are way too many M's, F's, or others, we try to run another hash function, h sub p1. But of course, all the records with M will end up in the same bucket again after recursive partitioning. So it doesn't matter how many times we partition recursively, this will continue to produce one partition every time we recurse. So we need a special case here to recognize that we have a partition that contains all the same value, and we can stop recursing at that point and just add that partition to the output. This can be done, for instance, by sampling the input data to see how many distinct values there are, or keeping track of the number of distinct values that the hash function sees during the divide phase.